Do you notice anything about all those powers? I mean, we already kind of talked about it, but all these powers are odd, right? Do you remember in pre-cal, you were told that sine is an odd function? Do you understand now why it's an odd function? Its infinite polynomial is all odd powers of x, and thus it is odd. What were you told about cosine? What do you think is going to happen when we do this for cosine? We're going to get a bunch of even powers of x. How am I doing on time? 20 minutes? All right, let's do cosine, and let's do it fast. All right, f of x equals cosine x. We're going to do Maclaurin. Ready? The Maclaurin for cosine. So I'm going to start taking derivatives. Derivative, zeroth derivative of this is itself. Plug in what? 0. Cosine 0? 1. Okay. Now take the first derivative, negative sine x. Plug in 0. 0. Take the second derivative, negative cosine x. Plug in 0. Negative 1. One more, and it's going to start repeating, right? Third derivative is sine x. Plug in 0. 0. And now from here on, it's going to be 1, 0, negative 1, 0, right? And just keeps on repeating. So with that in mind, cosine x, do it up here because I want to write it up. I don't want to erase that yet because I know I wrote that really fast. Cosine x should be the first number we got, right? 1 over 0 factorial x to the 0. I'm using the formula again, right? Plus the next number we got, 0 over 1 factorial x to the first. And that's going to go away. Plus, next number, negative 1 over 2 factorial x, hey, even, squared. Right? Next one, 0 over 3 factorial x cubed, but that one's going to go away. So no odd piece, right? And then the fourth one, we'll be back up here, right? So 1 over 4 factorial x to the fourth plus 0 over 5 factorial x to the fifth. Let's do one more. Negative 1 over 6 factorial x to the sixth plus dot, dot, dot. Let's kill off all the zeros and write out this nice series. So this is going to be, what's this? That's just 1, right? That's 1. This is gone. Actually, that's gone, that's gone, that's gone. All the odds are gone. This one is going to be negative, isn't it? So minus 1 over 2 factorial x squared plus, what's the next one? 1 over 4 factorial x to the fourth minus 1 over 6 factorial x to the sixth. What would the next one be? Plus 1 over 8 factorial x to the eighth. Right? Plus dot, dot, dot. Can you give me a formula for this one? It's alternating, starting what? Positive. So how about negative 1 to the n plus, no, just to the n. Oh, it starts the same way, doesn't it? Okay. Let's take care of the factorial part now. We have 1 over, this first one was over 0 factorial, wasn't it? So that's like 1 over 1. So 0, 2, 4, 6, 8. 2n factorial. Be careful when you write 2n factorial, it has to be 2n in parentheses factorial. It is not the same as this. That's not the same as this. So it has to be in the parentheses. And then what about the x? X to the 2n. Bam, there it is. There's your Maclaurin series for cosine. Even function. Pretty awesome, right? Now, let's not lose sight of something here. If you get on your calculator right now and you are in radian mode on your calculator, somebody get their calculator out real quick. It's out. Okay, just make sure you're in radian mode. Do cosine of 1 on your calculator and tell me what you get.
Cosine of 1?
Cosine of 1.
0.540.
0.540 what?
30.
30, something like that?
Yeah.
Okay. What I claim is that this is going to give you the same thing. So let's plug 1 in for x. So what would that be up there if I plug 1 in? 1 minus 1 over 2 factorial, that's 1/2, right? Plus 1 over 4 factorial. 4 factorial is 24 minus 1 over 6 factorial. I'm not quite sure what 6 factorial is. I think it's 120 times 6, 720, 720. Okay, plus dot, dot, dot. Now on your calculator, please, can you do 1 minus 1/2 plus 1/24 minus 1 720th? What do you get? Just, no, I want 1 minus 1/2 plus 1/24 minus 1 over 720. 5.4?
No, 0.5.
This is approximately 0.5402. Okay, 7. So look, I stopped at the 4th one, right? And I'm pretty close to what your calculator got, right? How did your calculator get this? It computed the series out to a certain place. It has no idea what cosine is. It just did this. That's what your calculator did. All right? And it has a pre-built, like, programmed, whoever wrote the program in that, for that machine, right? Said, I will go out in this series to a certain predetermined tolerance and stop. And so there's in your menu, you can adjust how far out you want it to go. Like, you think your float, I think they call it the float, and you can adjust how far out you want it. And that will mess with the code and it'll take your series out further. But that's what your calculator is doing. It's using that power series. Okay, that's fun stuff. Let's do another one. I have 15 minutes. I think I'm going to have just enough time to squeeze this in. All right. What about for e to the x? What is the Maclaurin for e to the x? Isn't this kind of exciting? What are you already happy about here? The derivatives are all the same, aren't they? So the 0th derivative of x is itself. And when I plug in 0 to this, because it's a Maclaurin, right? When I plug in 0, I get 1. And that's the way it's going to be the whole way, right? All the numbers that we get on top are always 1s. So that means when I start to write the power series out, if I follow the formula, it's the first number I get, 1, over 0 factorial x to the 0, plus the 1 again, right? Over 1 factorial x to the first, plus 1 again, right? 2 factorial x squared, plus 1 over 3 factorial x cubed, plus 1 over 4 factorial x to the 4th, right? You get the point, right? See, this is, the exponential function is neither even nor odd, right? Remember when you were studying even and odd functions, you could have neither. This is neither. It's not odd, it's not even. Does that kind of make sense why it's both? All right. Now, I'll do one more little thing here. This is 1 plus x plus 1 over 2 x squared plus 1 over 3 times 2 x cubed plus 1 over 4 times 3 times 2 x to the 4th plus 1 over 5 times 4 times 3 times 2 x to the 5th plus dot, dot, dot. I think I may have shown you this earlier in the semester. But check this out. It's so cool. if we take the derivative of this, what should we get? Itself, right? Take the derivative of this power series right now. Take the derivative of that power series. Let's see what happens. What's the derivative of 1? Derivative of x. Plus 2 comes out. Half of 2, 1 times x. Plus 3 comes out. 3 cancels, you're left with 1/2 x squared. Plus 4 comes out. 4's cancel. 1 over 3 times 2, right? X cubed. Next one, 5 comes out. 1 over 4 times 3 times 2, x to the 4th plus, and those are the exact same things. I just rewrote it, right? That's the exact same thing. It's the exact same expression. That's what e does. It is its own derivative. No other function behaves that way. All right, how about the sigma notation of this? What's the sigma notation that would give us this? I heard it. This in sigma notation should be sum n equals 0 to infinity. We always have 1 on top over n factorial x to the n. That is your Maclaurin series written in sigma notation for e to the x. It's exciting. All right, 10 minutes, I get to show you the most beautiful equation. Are you all ready for it? You are. You are ready. I know you're ready. All right, here's what I want to show. I'm going to try and prove to you right now that e to the I pi plus 1 is 0, right? That's what I'm going to try and prove to you? Yeah? Would you be satisfied if I could just show you this? Sorry, Laura, I'm going to disappoint you then. Yes, but that's the same thing, right? I'm not going to show this. I'm just going to show this. Is that all right? Okay. If I can prove to you that this is -1, then obviously -1 plus 1 is 0. That we won't debate about. All right, here we go. One more thing. I to the first power is I. What's I squared? This, you have to go back in college algebra, and the way we defined I squared should be -1. I is that special number that when you square it, you get a negative. Okay? What is I cubed? Well, that's I times I squared, isn't it? What's I squared? -1. What's -1 times I? Negative I, right? Okay, what's I to the 4th? Isn't that I squared times I squared? So isn't that -1 times -1? 1. What's I to the 5th? Well, isn't that I times I to the 4th? So isn't that just I? And what's going to start happening? It's going to start repeating. So we call this cyclic, okay? It's -1 does the same thing, right? -1 to different powers is going to cycle back and forth between -1, +1, -1, +1. I raised to different powers is going to cycle, but it's a 4-phase cycle. It's I -1, -I1, I -1, I1, right? Keep that in mind. All right. Remember what I'm trying to show you. And 8 minutes. All right, what is e to the x? Written in its power series. 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed plus ... right? We just did that? Okay. Then what is e to the I pi? Well, e to the I pi, this is my x, right? Okay, so this should be 1 plus I pi plus 1 over 2 factorial I pi squared plus 1 over 3 factorial I pi cubed. I'm going to keep going. 1 over 4 factorial I pi to the 4th. I need to go about 3 more. 1 over 5 factorial I pi to the 5th 1 over 6 factorial I pi to the 6th. One more. 1 over 7 factorial I pi to the 7th plus dot, 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 dot. Equals 1 plus I pi plus, let's go ahead and square this. When you square I, what do you get? -1, right? And then when you square pi, you just get pi squared. So here's how I'm going to write this. I'm actually going to take that plus away. I'm going to make it minus 1 over 2 factorial pi squared, right? The next one, what is I cubed? Negative I, right? Negative I. So watch how I write this. Minus 1 over 3 factorial. 1 over 3 factorial I pi cubed. Next one, I to the 4th. 1. So plus 1 over 4 factorial pi to the 4th. Next one, I to the 5th. I'm back to the beginning, right? So that's just going to give me I. So I'm going to have plus 1 over 5 factorial I pi to the 5th plus I to the 6th, -1. So negative 1 over 6 factorial pi to the 6th, I to the 7th. Where am I at? Negative I? Yes? Negative I, so minus 1 over 7 factorial, negative I, pi to the 7th, plus dot, dot, dot. I know that looks like a disaster. 5 minutes. I would like to group things now. Do you agree with this? 1 minus 1 over 2 pi plus 1 over 4 pi. Not 4 pi. I'm writing this down wrong. 1 over, I mean to write this one. 1 over 2 factorial pi squared plus 1 over 4 factorial pi to the 4th minus 1 over 6 factorial pi to the 6th, and that's it, plus dot, dot, dot. Those are all the terms that do not have I in them. Plus all the terms that do have I in them. I pi minus 1 over 3 factorial pi cubed plus 1 over 5 factorial pi to the 5th. I have one more, minus 1 over 7 factorial pi to the 7th plus dot, dot, dot. Yes? What am I missing out of these? Hold on. I'm missing I's. I'm missing I's in all these. I, right? Yeah? Those all have I's, don't they? Let's factor an I out. Factor out this I, factor out that I, factor out that I, factor out that I, and let's just stick it out here because it would distribute through. Do you recognize this? Close? They're even powers. They're all even powers. Isn't this cosine? This is cosine of what, though? Cosine of pi. And do you recognize this? This is sine of pi, but then times I. What's sine of pi? 0. What's cosine of pi? -1. We're done.
Plus 1 is
Cosine of pi is -1.
And then the one at the beginning.
Well, didn't I just show you right now that e to the I pi is equal to cosine of pi, which is -1? Isn't that what I was trying to show you? That's pretty awesome. Okay. I'm going to give you the homework assignment for this section, but you're not going to be able to do it all, so I'm just going to give you a little piece of it. Just for those of you who are like a little ambitious. Page 487. For now, 5 through 10. And remember, my videos are online for homework solutions. And I still have a minute. I'm going to pass the sign-in sheet around. I know y'all want to go. But I have a